Why the Makemake Dwarf planet is special. On the outskirts of the solar system, in a region we know as the Kuiper Belt, there are many small objects, including several dwarf planets. Makemake was the fourth discovered and one of the reasons that Pluto lost its classification as a planet a decade ago. But what is so special about this object? Let's find out. A group of astronomers observed Makemake at the Palomar Observatory located in San Diego, California in March of 2005. As a curiosity, the name of this object is pronounced like this, as it is written, as much as it may seem a repetition of the word make. 2 days earlier, the dwarf planet Haumea had been announced by a team of astronomers from Spain. This announcement was surrounded by controversy because it was made with data extracted from the computer of the Palomar Observatory telescope. This unfortunate event caused the Californian team to be forced to announce ahead of schedule the discovery of Makemake and Eris, for fear that they would try to snatch authorship again. Although Makemake has a relative brightness equivalent to 1/5 the brightness of Pluto, it was not discovered until after many other Kuiper Belt objects with a fainter apparent magnitude. What happened is that the search for minor planets is done near the ecliptic, an area where most of the objects orbiting the Sun are located, while Makemake's orbit is very inclined. Ironically, Makemake has a very inclined orbit. At the time of its discovery, it was situated at its most significant distance from the ecliptic, in the north of the constellation Berenice's Hare. Although initially classified as 2005 FY9, in July of 2008 it was renamed Makemake. This name corresponds to the god of fertility in the mythology of the Rapa Nui, the inhabitants of Easter Island located southeast of the Pacific Ocean. Makemake was the chief god, humanity's creator and fertility god. This object was discovered by the team led by scientist Michael Brown, the same one who discovered the dwarf planet Eris, and also participated in the discovery of the dwarf planet Haumea. Features of the dwarf planet. Currently, Makemake is the second brightest known object on the outskirts of the solar system, being only slightly darker than Pluto, and can be observed with a good amateur telescope. It has a diameter of 1,400 kilometers, 2/3 of Pluto, and its orbit is somewhat farther away. Still, it is closer than Eris since, while Eris completes a lap of the Sun every 558 years, Makemake takes 310 years to complete one lap around the Sun. It rotates on itself every 22.5 hours. It has a slightly shorter day than Earth's, and at its perihelion, it approaches 38 times the distance between the Earth and our star. At the same time, in its aphelion, it goes up to 53 astronomical units, has a somewhat eccentric orbit. Makemake stands out for its reddish-brown color, which led scientists to conclude that it must contain a layer of methane on its surface, probably in minor accumulations of 1 centimeter thick. Frozen ethane and nitrogen signals have also been detected on its surface. On April 23, 2011, Makemake passed in front of an 18th magnitude star and abruptly blocked its light, taking advantage of the planet's passage in front of the star, a phenomenon we know as occultation. This is somewhat surprising because Makemake has many similarities with Pluto. The difference is that Pluto does have a thin atmosphere. Astronomers also use that same moment to determine how much light the planet reflects. It is similar to the reflective capacity of dirty snow, making it somewhat dimmer than Pluto but brighter than Eris. The presence of methane and possibly nitrogen suggests that Makemake could have a transient atmosphere similar to Pluto near its perihelion. Perihelion is when the planetoid is closest to the Sun. If there is nitrogen on its surface, this will be its dominant component. The existence of an atmosphere also provides a natural explanation for nitrogen depletion. Because Makemake's gravity is weaker than that of Pluto, Eris, and Triton, a large amount of nitrogen was likely lost through atmospheric escape. Methane is lighter than nitrogen but has a vapor pressure significantly lower than the prevailing surface temperatures of Makemake, which are around -402.07 Fahrenheit. However, studies of Pluto's atmosphere by New Horizons suggests that the dominant exhaust gas is methane, not nitrogen. Therefore, the reasons for the absence of nitrogen in Makemake are still challenging to explain. Astronomers also found evidence of tholins on Makemake's surface. Tholins are molecules that form anywhere ultraviolet light from the sun interacts with substances such as ethane and methane. If tholins are present, they usually cause a red-brownish color. This reddish color was seen during the observations of Makemake. Thanks to that, we know that the planet has a dark reddish color, similar to that of Mars, but without ice caps or significant rocky elevations such as mountains or volcanoes. But it must be covered with impact craters, since it does not have a geological system that renews its surface. As for its relief, it must look a lot like the dark side of the moon, a place with many craters but on a reddish surface. However, this object is so far away that all this is only a hypothesis, since it has never been photographed with cameras aboard exploration probes as done with Pluto. Small, but with moon. In 2016, a team of astronomers reviewed Hubble Space Telescope observations captured in April 2016, and it announced the discovery of a satellite about 175 kilometers in diameter orbiting Makemake at a distance of approximately 21,000 kilometers and a period of about 12.4 days. This object was baptized as MK2. By the images of the Hubble telescope, it seems to be as dark as coal, something that is very striking for how bright the surface of its host Makemake is, and that could be explained because the gravity of the satellite is too weak to retain any ice, which sublimates from the surface of MK2 into space. Its finding is beneficial because it will allow us to study Makemake in more detail. It also helps us understand the nature of dwarf planets better and determine if the presence of satellites around them is uncommon or not. In future observations, astronomers also hope to determine MK2's orbit type. If it is circular, it would mean that the origin of the satellite is probably an impact that happened a long time ago, in precisely the same way that Pluto's satellites were created. Conversely, if it has an elliptical orbit, it would indicate that MK2 was a free-moving object in the Kuiper Belt that Makemake captured. Guilty that Pluto is no longer a planet. Between 2002 and 2005, a team of astronomers led by Michael Brown of the Palomar Observatory in California discovered a series of bodies in the Kuiper Belt. Several of these bodies were about 1,000 kilometers in diameter, like the protagonist of this video, Makemake, and a pair had sizes comparable to Pluto, such as Eris or Haumea. In addition, since 1801, Ceres has been known as a body almost 1,000 kilometers in diameter that orbited within the asteroid belt located beyond Mars. Faced with these discoveries, doubt arose. If both Makemake and the rest of the objects shared so many characteristics with Pluto, should these bodies be included in the list of planets? If so, we would have about 15 planets in the solar system, the largest of them being more than 100 times wider than the smallest. But if we decided not to include them, it would mean that we were arbitrarily choosing Pluto as the lower limit of what constituted a planet. In addition, there was a risk that in the future, we would find an object slightly larger than Pluto. In this case, we would have to add it to the list of planets. To solve this, on August 24, 2006, Pluto, until then considered the 9th planet in our solar system, was reduced to a dwarf planet. That year, the International Astronomical Union determined that to qualify for planet status, a celestial body must meet 3 conditions. 1. Orbit the Sun. 2. Have a mass large enough to make its shape round, thanks to the effect of gravity. 3. Have cleared its orbit of other objects. Pluto shares its orbit with other bodies, so by a vote of the International Body of Astronomers, it was left out of the definition, and from then on, our solar system is officially composed of 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and 5 dwarf planets: Ceres, Haumea, Eris, Makemake, and Pluto. Before we move on with Makemake's habitability, be sure to stay tuned afterwards to watch our earlier release on What's Strange Happening on Pluto. Makemake habitability. The temperature on Makemake is usually around minus 406 degrees Fahrenheit. Life as we know it cannot exist in such cold places, so this object is one of the places where it is 100% certain that we will not find any form of life. Plans for Makemake. From recent calculations with current technology, it is estimated that a flyby mission to Makemake could take approximately 16 years with the help of Jupiter's gravitational assistance. Based on a launch date of 2024 or 2036, Makemake would be about 52 AU from the Sun when the spacecraft arrives. However, there are still no expeditions established for Makemake, although its mystery and our lack of information about it is undoubtedly a strong point for a future expedition and continuous observation. For now, Makemake has no scientific interest since it cannot house water and living beings and does not have enough gravity to retain an atmosphere. So we will have to wait a long time to know more about this distant world in the far reaches of the solar system. Would you like us to make videos for the rest of the dwarf planets? Let us know your opinion in the comments.